Hey guys, welcome back. So this is the preview of the test and I think it's looking really cool. I think it's better than the original one I did. The only thing I don't like is how much force Kong is applying on the particles, and we can fix this using two methods. We can either reduce the amount of force the amount of force it's been transferred from Kong onto the particles, and that's really simple to do, or we can clamp all the particles using a speed limit node, and I'm gonna do that now just to show you. So we can either tweak it by multiplying the value or just try to calm everything down. Now another thing that I really like, or something that I really like, and I think we should put more emphasis onto it, is how the particles are clumping and separating. So if we look here, see how there's nice distribution of points, and then they're getting separated with all that noise and stuff, and as they're falling down, they're getting affected with the noise and all. And I want to add one more thing. I want to add a second noise that affects anything that falls down, but 2 times more, but narrow the range of the height, so it only affects maybe from here to here, but it's stronger. And so if anything falls down and reaches that height, we can affect them. Another thing that we can do is we can use the age as well. So as the particle is getting closer to die, we can use the last bit, the green bit that we did, the blue bit, sorry, and use that as a multiplier to add another force. So if as they get closer to dying, they get disturbed, but we don't want that to happen on the particles that are on the ground, for example, so we use a height to mask them. And these are all options. This is a particle sim. There's nothing crazy about it. It's just what you would like to achieve. But I think the most complex and unique features, most complex about this system, is the collision and interaction with high-res geometry, and then the trick is to use the dot product. Those are the two main things. I have one more trick that we're gonna talk about in the next video, but for now I want to implement a speed limit. So pop speed limit, and I'm gonna say the maximum speed is, let's start with 10. And let's go up, and let's hit play. And I'm gonna wait up until that part comes. Yeah, so the speed limit that we put in is very high. That's why nothing is moving now. So let's go back and let's say 25. This one. Yeah, so you see the color here. And an easy way to know what the limit is, so I think this limit is pretty good. Maybe a bit more, maybe 40 would help calm the particles down. Yeah, definitely. I think this range is much closer now, but maybe we give it more room. No, I think it's pretty good. Yeah, it's much better. And I think this is realistic, because if you have this much dust that is very light, it's gonna react in this way. We could add some more breakups, but look here, it looks almost like a splash, this part and this part as well. So I think I'm pretty happy with this. Maybe you could go a bit more, and all this is looking really cool. Okay, so I think that's pretty much it. Maybe we go a bit higher, 25, sorry, 30, maybe 35, I don't know, it's up to you guys. So I want to show one more thing with the emitter. I didn't count the particles, but we have how many? Let's say at this point we have 19,000. So we can't increase the emission too high with these points, but we can do a trick to multiply them. And the first thing I want to do is I don't like how all these points are nicely distributed, and that's because of the geometry. So I'm just going to add a jitter and break them up a bit. 0.1, maybe 0.025, 0.5, something like that. So it will just get some breakups, that's all. And then what I'm going to do is I'm going to use a point replicate. I'm going to set this to 4. I don't need to increase this too high. And I'm going to set the noise type, the type to point. And we just want the copies to be on top. So we have 16 now. We should have about 4 times more that. And sorry, which one? Yeah, sorry, I'm going to set it to sphere, not point. And let's reduce this to 0.05. And I'm going to use this velocity stretch because it helps a lot to break the pattern. So let's reduce this. And see how it's stretching the points along the velocity vector. And this is really nice way to multiply the points. So it's gonna respect how the points are transforming. And maybe let's reduce this to 0.1. I want to get some nice small trails. Yeah, something like that. Okay, let's connect this. It's 4 times more particles, so it's going to be a lot slower. And not a lot slower, but it's going to be slower. I also don't want to use this node because it doesn't multi-thread very well. I'm going to use a pop force. And how much do we have now? -4. I'm going to set it to -6 just to increase it a bit. And let's go up. Let's hit play. And now we have a lot more particles, 4 times more particle to be precise. And let's see. So I would be looking at around probably 8 to 15 million for this sim, maybe more if we wanted to get more details. But we have to be careful because it's not about adding points only. We have to add points and make sure that they're not overlapping too much. But this, I'm pretty happy with this sim. I think it looks really, really cool. All the noise and everything, I think it's very cool. All these patterns. It's much better than the first one I did for sure. So this part. And one thing I did quickly, and I didn't think I talked about too much, and that is this. So if we go here, I reduce the inherent velocity to 0.1, and what that does is, if these points, they have velocity on them, if we kept this velocity at its original speed, the trail will be shooting way past the points, and we don't want that. We want the trail to be lingering behind the emitting object, and so that's why I reduced the amount of velocity we're inheriting to that number. Okay, I'm gonna let this cache, and let's take a look. Again, as I was saying, we could add another noise and another noise that only affects another area that is closer to the ground, maybe not too close but not too high, and use a different velocity, a different noise. We could also use the age attribute, just the blue range, and connect the blue area and add a noise where they're getting closer to dying, we could add a different noise. And you also use a height mask so we don't affect anything that is on the ground. Another thing that we could do is if anything touches the ground, we could kill right away. So we can have an if expression with a pop wrangle saying if the height is 0.005, delete the point right away, and that way we don't have anything lingering or interacting too much with the ground, which could help in some cases, but it really depends on the visual that we're looking for. And let's see, so this is a preview, and this is with more points. Yeah, it's working pretty well. And so with the other emitter, let me check. That would be, let me find it. So the intersection emitter. Yeah, I really like this explosion here. You know, it feels very natural. But we're gonna add one more really cool thing to all of this. I probably should stop the recording. Let's get to a frame 100. And so with the intersection, everything is the same. We're going to swap the source and feed it. Everything is pretty much the same. We can even do both of them here and run the sim, and then later we can separate them based on the source group. Cool. Yeah, it's working. Okay, let's hit escape. Let's see how much points we have. 9 million. So yeah, this resolution is pretty good. We could always increase the number of points as a post-process if we needed more details. We could also go really high with the number of points. Maybe even 90 million if we wanted to. But what I was looking for in the sim, if you guys look here, the dust itself is very light, because I didn't want to hide the destruction. I don't want to obstruct everything. And so if we make all of this, it's going to hide pretty much everything. And that's really up to you and the artistic decision that you're working on, and whatever the vision for this shot is. If you need more dusty look, this is the way to go. You just push more points here. And if you need more volumes, if you need volume based, then we're going to talk about that next week. Or if you need lighter, you can just reduce the particle size when you render, and then it's going to look a lot lighter. Okay, so what was I talking about? Yes, we're gonna change the source. So let's do a file, and this is the second source, and this is the intersection source. And for this one, we need to use the velocity and delete anything that doesn't have any high velocity, because it's just checking for the intersection and we don't want to emit from everything. So I'm going to use this node. I'm going to remap using the velocity, and let's say maybe 0 to 5, and let's set this to red, or yeah, let's set this to red and this to blue and this to green. So maybe not the blue parts. Maybe 4. Okay, let's delete everything that is not red. And I'm gonna delete this. Set this to white. And this to black. Okay, yeah, better. So let's delete. CD higher, less than 0.2. We want to delete the points. Still have a lot of stuff on the ground, so let's try 10, maybe even 20. We could use the height as well if we wanted to, but I'm gonna capture more points because I want the intersection and show more of that, and I'm gonna delete anything that is less than the height is less than, maybe delete non-selected 1. Sorry, not X but Y. Okay, that's too much. Something like that. I'm gonna use the pop replicate for now, and I'm gonna use a switch node. Switch to 1, and let's see how this looks. So with this type of, with the intersection, we may want to use more velocity from the gradient so that the bounce of the debris is higher, because it's based on the intersection between the pieces. But again, it's really up to you guys, what the visual, what kind of visual you're looking for. Yeah, it's working. It's really cool. Let's hit play. Yeah, I think we would want to use some of that velocity, or more from the velocity, or even the source itself. So let's take a look. Yeah, so here we may want to invert the velocity. Let's try. I'm gonna disable all of this and set this to 1. Let's hit play. Okay, so this is too much, and let's try negating this. Yeah, so this would work better. And I'm gonna add some variation here. I think that's too much, so let's try this. And let's enable all of this. I'm not sure about inverting the velocity, but let's try and see how it looks. Yeah, I think it works. Yep. All right. And that's pretty much it for the particle sim. I'm gonna create another force and apply it to the particles, and this is gonna be the wind field or the air field. Let me switch this and disable the point replicate for now. And what I want to do next is create an air field, so that, because as Kong travels through this environment, if I just find Kong, as Kong travels through this environment, if his hand, for example, is swinging in a very fast way and there is dust on the ground, that dust is going to be affected by the wind and get kicked up. So that's the thing that